Welcome to the CIS and Cybersecurity programs at LCCC. In this video, we're going to talk about binary and binary mathematics. Binary is the function of how computers think, how they work. So computers do not work off of magic. They do not work off of any special powers. They work off electricity and math. The electricity is used to switch on and off. A processor in a computer does all of its complex mathematic formulas by using binary math. And the principle behind it is we're turning a circuit on and off repeatedly. So what that looks like, we represent that circuit being on or off in a function we call a bit. Now, the bit is a representation of that transistor being on or off, and we represent on or off with a 0 for off or a 1 for on. So within each bit, you have two possible values, 0 or 1, off or on. Now, in computers, we lump bits into groups of 8. And we call those bytes. All right? A byte is 8 of these bit values put together. So here's how we do binary math. Binary mathematics work reverse from what you're used to. They're going to work from right to left. So we're going to take our first bit out of our byte, and we're going to go ahead and write up a quick note up here. It says a byte is equal to 8 bits. We're going to take our first bit, and we're going to give it a value right here. We're going to give it a value of 1. Because the most combinations you can have out of this will be 2 combinations, right? You can have 0 or 1 for 2 combinations total. So the first bit has a value of 1. Our second bit gets a value of 2. We're going to double every time we move a bit position. Our second bit gets a value of 2. Now this second bit can get a value of 0 or 1, but we have now a total combination set of 4 total possible combinations. Because out of those 2 bits, we could see it be 0, 0, 0, 1, 1, 0, or 1, 1. So we can see 4 different total combinations of those 2 bits. Our next value, because we're going to double it every time, is 4, followed by 8, 16, 32, 64, and 128. So that is our 8 bits within a byte. Now, if we wanted to go to a 9th bit, we could. We would just say, okay, we're going to double it again. So our 9th bit has a value of 256. And the reason that we do this doubling values is because of the fact every position has 2 possible values, then we're doubling the total combinations we can have in any set. So for example, bit 4 has a value of 0 or 1, but because we had 4 total combinations with just those 2 bits, if we double having 0 and 1 as possible add-ons in the 3rd bit, now we have a total of 8 values. 16 values, 32 values, 64 values, 128 values, 256 total possible combinations or values out of that set. And then the next one, if we did go to the 9th, now we can represent this fairly easily. We can use a formula of 2 to the power of n to represent that, where n is equal to the bit. Okay? So if we're in the first bit, 2 to the first power is 2. If we're in the second bit, 2 to the second power is 4, etc., so on and so forth. When we're in the 8th bit, 2 to the 8th power is 256 total possible values. This makes it really easy that you can look at how many bits you're working with and get the total possible combinations or values in there. Now, how we use this? Within this, we can use these combinations to give us specific math and specific sets. So what we can do, we can represent any number between 0 and 255 with these 8 characters of zeros and ones. Now, everybody says, well, you said there's 256 values. I did. In computers, in binary, 0 is a value you have to consider. If we add up all of these binary values together, we will get a total of 255. So we can have anything from 0 to 255 be represented by these 8 bits. So let's take a look at what that looks like. I'm going to erase some here so you can see this. We're going to do some binary math. So if we want a value of, we'll say, 137. And the way we can do this, we can activate each bit to turn it on or off to give it its value, right? So we can say 137. Can we subtract 128 from 137 and have a value at or more greater than 0 remaining? And the answer is yes, we can. Since we can subtract 128 from 137, we're going to turn this bit on, just like that. Because remember, 1 represents on. We have a remainder left over of 9 now. So can we subtract 64 from 9 and be 0 or greater? And the answer is no, so we're going to leave that bit off. Can we subtract 32 from 9? No, that bit gets left off. 16 from 9? No, that bit gets left off. Can we subtract 8 from 9? Yes, we can. So that bit gets turned on, and we have a remainder of 1, meaning that 4 gets turned off, 2 gets turned off, and 1 gets turned on. Therefore, 137 can be represented with the binary of 100, 01, 001. Let's do another one. How about 242? So can we subtract 128 from 242 and have a value of 0 or greater left? And the answer is absolutely yes. So we're going to turn this one on. And we have a remainder now of 114 to still work with. Can we subtract 64 from 114? Yes, we can. So we're going to turn that one on. Now we have a remainder of 50 left. Can we subtract 32 from 50? Yes, we can. We now have a remainder of 18 left. Can we subtract 16 from 18? Yes, we can. We now have a remainder of 2 left. Can we subtract 8 from 2? No, we can't. Can we subtract 4 from 2? No, we can't. 2 from 2? Yes, we can. And our remainder is 0, making that last bit a 0. So our new binary is 11110010. And that is binary for 242. The reason we need to know this and the reason we work with this is that when we do networking, specifically IPv4 networking, we work with something called an octet. Now, an octet is a representation of 8 bits. So we will convert numbers from 0 to 255 into binary digits like this. It becomes very important because it's the logic behind how the computer works. It works in binary, it looks in binary. It'll become very, very important that you understand how to do this type of binary math. Let's do one more. Let's do 78. So with 78, we can say 128, no. 64 is a yes. Sorry. 32, no. We have a remainder of 14 currently, by the way. 16 is a no. 8's a yes. Now we have a remainder of 6. 4 is a yes. 2 is a yes. 1's a no. And that's 78. Binary math is not overly complex. It's not terribly difficult. Don't make it more so than it is by getting confused in your head. So I want to review now what we've learned thus far. Binary is a method of demonstrating whether a value is on or off and getting large-scale values out of the system by that resultant on or off state. By changing our combinations of values, by changing that on or off state, we get a total number of combinations equal to 2 to the power of n, where n equals the number of bits that are being talked about. Okay? So the next part to consider about binary, and a tough concept for a lot of people to really wrap their head around, is the concept of buckets and how binary math counts up. So the basic math of just doing a little bit of subtraction and turning values on or off is not terrible. But when we start talking about how binary counts up, it gets a little trickier. So think of it like this. For a value of 1, then the first bit would have to be on. Right? For a value of 2, what happens is, let's just count from 0. At 0, a value of 0, then all bits are off, right? But we're only going to focus on these first 2 for the moment. For a value of 1, then we would have this bit on, this bit off. For a value of 2, this bucket is full, so it has to pour over to the next bucket. So for the value of 2, it's poured over, thus emptying the first one. For a value of 3, then what happens is this bucket is still full, and now we're going to fill this bucket back up. So now we've got 0, 1, 2, 3. Now to get to a value of 4, we're going to go to another bit. And we would have looked like this thus far. So now, since these 2 buckets are full, we're going to pour over into this one. But by pouring over, we're emptying these. Now we have a value of 4. So the next thing that's going to happen, because we always work from the right, this bucket is still full, this bucket is empty, but we're going to fill that first bucket again. Now we have a value of 5. Since this bucket is full, that one's still full, now this one fills and this one empties. We have a value of 6. And now we fill all 3 buckets. We have a value of 7. And I've wrote below what you can see. My bad. So, that's the principle of binary math in buckets, and that will happen all the way across. We could go all the way through the system, 8 bits, and we'll constantly fill a bucket and empty, fill a bucket and empty, all the way up. That is one of the tougher concepts to learn, but it's going to be critical as we move into the next section, where we start breaking down binary math, and then we move into decimal, and then we move into something called hexadecimal. Hexadecimal is really wild. It is used in IPv6. It's used in physical addresses, also known as MAC addresses. It's used in the ASCII format. It's got all kinds of fun stuff to it. Hexadecimal, though, is a way that we can represent pretty much anything we want, any character or set we want, with only 4 bits. It's pretty wild. All right, I'll see you in the next video. In the meantime, if you have any questions, please feel free to reach out. You can reach me through Canvas message or through email, or call and leave me a message on my office phone, and I'll respond to you as soon as I can. Thank you, and have a great day.